Okay. Very quickly in 1 minute, let's revise what we did last time. We started with the atmosphere, and we said that, well, the atmosphere what we see today was not the atmosphere that was kind of we started with, and atmosphere got changed and changed substantially and changed in such a way that today's life or today's world what we see can be sustained. Okay? And we also said that one of the important physical parameter for the atmosphere that was important was the pressure. Okay? And we also derived an expression to see how the pressure changes with height. Okay? And then we also said about the temperature profiles. Okay? And we saw the temperature indeed changes, and changes very not in a monotonic function, but it changes depending on what height you are. It may increase, it may decrease, it may be probably the same, and that kind of thing. And that has lots of implication in terms of air pollution studies. Okay, that you will see later, because temperature equation we did not derive. We leave it for the later part of the course, because it's not that straightforward as the pressure term was. Okay. If you recall, we had just started the pollution systems. Okay. And that's what we'll discuss, and we'll continue from there wherever we left that. And if you recall, I kind of summarized the whole environmental engineering, just not the air pollution, in 3 letters. That was STR, source, transport, receptor. And you would really wonder that everything what you do in environmental science, engineering, is just within the framework of these 3, S, T and R. Okay. So what I'll do is, I'll try to do the same thing in terms of the STR, spend a little bit more time. And so if I start with source, let me draw the source for you. So what you have is the some kind of industry can be a source. Okay. There can be, if I can draw it, automobiles can be a source. Okay. So source, whatever you can think of as the air pollution sources. Household heating can be a source. Okay. So there can be many sources. So we need to study the source in this course, or source or sources if you like. Okay. Okay. When we say sources, just saying the source is not enough. Okay. So what we should know about the source? Its quantity. So we will learn in this course. Okay. Now we are trying to characterize the source, what we mean by the source. Okay. So we should understand its quantity, or somebody may like to say emission rate or something. Okay. Okay. You also need to say, well, it's just not the quantity, but what are the specific pollutants that we talk about. Okay. So you also want to define the pollutants. Okay. Third thing, if I want to really characterize a source, what are the other things which is important for me? Just take some clue. I want to define, we have a power plant here, Panki power station. I want to say about that air pollution source. I want to characterize as a scientist. What else do I need to say about that source? At what height it is being released is very important. So when we study the source, we are not only say about this, but we say height. We also need to say the physical parameters like temperature, pressure, Okay. We need to say, it's also important sometimes to say the velocity. We are just talking at the source. We haven't moved to the atmosphere as yet. Okay. So velocity of exit. Okay. So these are little things that are, at least without really reading or without really knowing the air pollution, we can still comment onto that. So this is what is the source. Okay. So we'll study about the source. Okay. Then comes what? If I can draw the components as we had discussed. Now the thing starts traveling. So they say the pollution is now traveling. Like I said, this is the plume. Okay. So what happens here? Here is a now we said source. Now let's just call this as the transport. Well, a little bad handwriting, doesn't matter. The transport. Okay. For the transport, what are the important parameters that we need to just, like what you feel, what is important to understand the transport of the pollutants? The wind, right? The wind speed. So let's say what we need to study and understand here is the wind. Wind in all aspects, wind speed and direction. And direction. Okay. What else? Water. Moisture content, he says. Okay, fine. We need to know something about moisture. Also the temperature of the atmosphere. That also defines many things. Okay. Okay. So you need to know the wind speed, the wind direction, the moisture, the temperature, and when you are putting, let's say for example, a pollutant in the water, and you understand water very well, what happens to the pollutant? It disperses, it gets diluted, and what else? It degrades through either chemical reactions or biochemical reactions or sedimentation or coagulation. It changes all the time. Okay. So apart from the physical factors which are responsible for the movement or the transport, we also need to know the, if I can use a word, transformations. And mostly it can be physical transformation or chemical transformation. Okay. So physical transformation can be, it could be the removal mechanisms. Okay. So here what I can say apart from this thing is also what is important for me is atmospheric chemistry, and let's not forget, and physics. Very, very important. Okay, so we want to know about both atmospheric chemistry and physics, and there's another important thing which happens in the atmosphere and not happen so much, or well, doesn't happen in the water pollution, is also you encounter what do you see? Look at the sky, monsoon time. What do you see? You can see clouds, okay, and the rain falls. Okay, so there can be, when we are talking about physics chemistry, we should also say it can encounter the rain also. Okay, so it can be rain. So when I am talking the transformation, you understand through the chemistry. The physics part is, physics also takes care of the dispersion, dilution. So this is what we are talking about, the transport and to the same extent transformation and removal, because it's all happening in a large container, if you can say. Okay, so that also we need to know. And there is something called a constant deposition of the the gases and particles on the surface. So this is the rain, if I can say this rain washout, and this is like, so you can say dry deposition. Correct? Okay. This all is happening. Okay. So we need to understand this. We need to be very thorough with this. Okay. And I should also say so there is a transformation and the wind speed, wind direction. So apart from this, there is also the 2 Ds which are very important, but we will define them in a more detail. Dispersion, diffusion also are important things which is happening in the atmosphere. Okay. When you study the part of the study which decides the diffusion, dispersion, movement of air, and how the air travels and how the atmosphere is behaving in terms of the movement of the air, that study we call as meteorology. Okay. So in a way we are also studying the atmospheric chemistry and physics, fine, but in addition to that, the other science that will try to understand, which has more to do with wind speed and wind direction and the transport of the wind, okay, which includes the cloud and rainfall and things like that. So at some point the study of the atmosphere in terms of the dynamics of the atmosphere is, that's what we call as the meteorology. So we should not forget the general terminology of the atmosphere, which is dealing with wind speed, wind direction, the pressure, the cloud formation and things like that. That's what is a meteorology. T-O-R-O-L-O-G-Y. Okay. So you see, already in the air pollution we are becoming very interdisciplinary, okay, and we need to know processes, because you can't understand the source unless you understand the processes in the industry. Okay. You also need to know the chemistry part, you also need to know the physics, you also need to know the meteorology, and you also need to know the how the pollutant solute move through rain and deposition. It can be a very, very big course. Okay. But then finally where do we go? To the, you remember what I said? S, T, R. R was receptor. So let's talk about the receptor, because we are still in a way defining the course. Receptor. Okay. Well, receptor can be, there can be water, there can be aquatic life in the water if you like. They do a good job. Okay. Okay. There can be trees and plantations and things like that. There can be crops. There can be its own ecology if you like. Okay. And there's a one person sitting very smartly here is the man. Okay. So you have this, and we have the, well, I cannot draw such a good picture. So let's say animals. Okay. So you have everything. There can be aquatic ecology, there can be trees and plants and crops, and let's not even forget that we have the other things which can affect the air, which can be affected by the air pollution is what? Other than the ecology, what else? We all know that, for like in a broad sense we all know that it could affect the human being, it can affect the crops, it can affect the trees, it can even affect the aquatic system, the air pollution we are talking about. What else it can affect? Total ecosystem, we have covered that. Apart from that, which is still not quite part of ecosystem, but it has a very strong influence or a strong effect of the air pollution. One is, of course, you can say the climate or like the atmosphere itself, you know, what she is referring to it. So we can say sometimes the pollution can affect the way we have seen how the atmosphere changes with time. Okay. And our activities now, we are in the situation and we recognize as a science or scientists that the atmosphere itself, which we are talking about, the secondary atmosphere, who knows that slowly we are going into a tertiary atmosphere. Okay? Why things are changing? Ozone is being disturbed, CO2 is going up, methane is going up, then in a way we are changing the atmosphere. So receptor can be atmosphere itself. In a way she said that. It's a little funny, but this is correct. I'm using the word atmosphere itself can be a receptor, which is it gets affected, and if that gets affected, somehow everyone will be affected. Every little bit thing which we are writing. So atmosphere itself is changing. Apart from that, still something which I have not written and you think that is very important in terms of the effect of air pollution, and that must be taken as the receptor. What's in Agra? Monuments. See, it's not part of ecology, the monuments or the buildings or the property. Okay? How everyone, like everyone talks about air pollution effect on Taj Mahal, and Taj Mahal this is happening and that is happening and blah blah blah, and we are spending lots of money to save Taj Mahal and things like that. So let's not even forget that we have, if I can draw this of Taj Mahal if like, well, very poor drawing, but some buildings. These are the buildings and windows and things like that. So if I can say receptor is also building, or in general term let's write property. Okay, even that are affected. So receptor, when we talk about the receptor, we are not talking about just a human being or a plant or a tree. Everything, whatever is get affected from the air pollution effect, which are started, transformed, still reaching to the receptor. And the simple objective of air pollution or any pollution control is not quite worry about this, worry about this. If there was no trouble here, who cares what is being emitted there? If there was no problem here, who cares how it is transformed and transported or being removed or not? Objective or the goals are very simple. It's always difficult to achieve that goal, okay? But objectives are very simple. The objective of air pollution or water pollution or soil pollution is to simply to safeguard the receptor, so that the bad effects, so that the ill effects of the activities which you are doing are kind of insignificant or tolerable, if you like. So that is what is the system we are talking about. So so this entirely this covers the receptor. Interestingly, this is just not the effect on the building per se, that it is causing the corrosion or the erosion of the building and things like that. But what is even more important is what the economics would like to say, the value of the property is also affected because of the air pollution. You might have a very beautiful bungalow or a mansion, hi-fi mansion, and suppose that mansion is located in an area which is highly polluted. The valuation of the building now will drop. So in that sense, in the economic sense, not in the scientific sense, we can also say that even the real estate is affected by air pollution. So even that can be affected. So this is what is the thing. If I have said that, okay, what is my objective here is to safeguard the purpose of air pollution or any pollution for that matter is objective, or the purpose of what all the degrees we are trying to get is to safeguard or save or safeguard the receptors, which includes everything, okay, receptors, to safeguard the receptor from, if I can use ill effects ill effects of okay. That's what is the objective of this thing. Okay. Okay, now you understand these are the people with process people. They will tell you what is the process, what are the emissions and things like that. These are some people with the chemistry background and some people with the meteorology background. And who is the people and who are the people who can tell more about these things, about the facts? Let's talk about who can tell in a better way how the man will be affected because of air pollution. To some extent, medical science people, people who are expert in toxicology, right? They can say, oh well, if you are exposed to such and such level of particulate matter, you will probably have bronchitis, or you probably will have some lung disease or something. Or somebody who is a little bit more into it, then they say, oh, you are exposed to the benzene, you are likely to get leukemia down, at the later age or something. The cancer generally happens at the later age. So that also somebody can say this. So this is another science, okay, that will decide as to what is the effect, okay, what is the effect, and you might need the person expert on the materials who will say what is the effect on the Taj Mahal, okay. There may be another person who will say the effect on some other kind of building which are not made of this thing, okay. Somebody you might need another expert which is like the aquatic ecological expert, that there will be the deposition of the pollutants and what will happen. You might need a botanist, okay, a plant pathologist if you like, to tell us something about this one, okay. So this again, what I am trying to say is the receptor or receptors is again a very it's an expertise thing, and we are more into the arena of interdisciplinary subject, okay. So what I'll do now is that with this the system of air pollution, we will try to define air pollution, okay. Because I needed this background to define what is really air pollution, and the definitions become important because the definitions are sometimes, they have some, I don't know to use the word legalistic value, but definitions are very standard written explanation of the something. So that's why we need a very, very standard definition, so that we are not talking vaguely about the subject definition. Life is full of vagueness and things like that, but definitions are very clearly written. I think you will recall the definition of the valency, for that matter, what you read in class 9, 10th and things like that. That is standard, okay. The definition of if you're the civil engineers, the definition of influence line, I don't know if you ever studied. Very standard definition. With the teacher would expect that you write every word properly when the definition is asked. So what we'll do is try to define the definition. So now the question is, well, the objective is very simple, okay. Safeguard. So I mean, can we expect that concentration of the pollutants which are emitted from the source will necessarily, that has to be zero, or can that be zero? Can SO2 be zero? Like you go to the cleanest part of the earth, you go to the North Pole or South Pole, you will still get, there's some SO2, there's some NO2, there's some lead, there's some chromium, some cadmium, some organic compounds, and some of the levels of the benzene you can find there, provided you are able to measure it, okay. So if that is what the thing is, that well, we are not talking about zero pollution, okay. So what will happen, that at some point, okay, there has to be some level that has to be acceptable, or at least some level on which the effects are almost not there, okay. So we are not talking about zero concentration, but we are talking about level at which the effects are tolerable, okay. So we try to define that now we are talking about more of the control part. We are trying to say, well, if this is what is the thing, and then we know the objective, and then once you know the objective, you should try how to achieve that objective, right. So to achieve this objective, you must say, okay, how to protect them, okay, what level of the pollution that will protect them, You don't want to overdo it. You're all engineers. You want to protect the ceiling doesn't fall. But then in the process, you don't want to overdo the design of the columns. Okay. You don't want to overdo the size of the slab, the thickness of the slab. So there is something, well, fair enough. Well, this is what is tolerable. With this one, we have no problem. Okay. So exactly. So we try to define the air pollution not in terms of the source, not in terms of the transport, but in terms of the impact on the receptor. So I'll try to give you a standard definition for air pollution, which I'll have to write it, unfortunately. And this is to do this background is to reach the logical definition of the air pollution. Okay, so we say air pollution is presence of any substance where in the atmosphere that it definition is something we should write very correctly. It may or may tend to cause, may tend to. Okay. See, that's why I say the definition is a very tricky thing. Okay, you have to get the right words. It's not something that we are talking and then we can talk little, for definition. And in fact, I'll go back and correct the definition, what is written there in my computer. The presence of any substance in the atmosphere that, let's change this one, or just say in, or maybe I can write it a little later. The presence of any substance in the atmosphere that it may or may tend to cause, let's add this in here because I'm sure it's there, or I think I'll rub it again, in such a concentration that it may or may tend to injurious to human, plants, build or property, if you like. Okay, this is something very close to what you will get, but I'll read for you and send it through the email. It says presence of any substance. Okay. It says presence of any substance, you can correct that, solid, liquid or gas. It's trying to be very, very clear in the definition. Presence of any substance, solid, liquid or gas in the atmosphere in such a concentration that may or may tend to be injurious to humans, animals, plants, property or to the atmosphere itself is referred to as air pollution, and the substance as air pollutant. Okay, so maybe we will send that one, but something very close to what I've written. Presence of any substance which you may like to change into solid, liquid or gas in the atmosphere in such a concentration that it may or may tend to be injurious to human, plants, property and to atmosphere itself, and that substance is referred to as air pollutant, and the system where such concentrations exist, that is called as the air pollution. Okay, good. So, so now the focus suddenly shifts to the receptor. Now we are more trying to be understanding some kind of control or something. What is the key word here in the definition? Most important word or words which you can think of. Concentration. Okay, the whole thing is focused around this little thing. Because all our efforts are focused onto this. Okay. For the time being, we have forgotten the source, we have forgotten the meteorology, and we are suddenly focused onto this. Because my objective is also focused on this point. Okay. If I am achieving this concentration, I don't care what are the sources, what are the meteorology, what are the transportation system, and what are the things. Okay. So the suddenly focus becomes such a concentration. Okay, and then what I'm trying to say, if I'm achieving this concentration, it means the air pollution is within control. Okay, or I'm fine. And if it is not within that such concentration, I need to do something else. Okay, and I need to do at the control of the source or something. But these concentrations are sometimes. And then everything you see, now the entire air pollution management, if I can call, centers around this concentration. Funny, but this is correct. Okay, everything what you want to do at source, everything, all measurements you want to do, the meteorology you want to study is all centered around this little concentration. Okay, and this is what this thing is defined or called many names. Okay. And then we'll say what are these names. Sometimes we call it air quality because it's the air quality standards. Okay, somebody may like to call it air quality goals. Somebody may call air quality guidelines. Okay, now the focus suddenly has shifted to that thing. Okay, and then you can just imagine, like, we are not talking so much of science, but we are talking more of the management. Everything is centered around these numbers. Okay, so there should be a lot of thoughts, lot of energy, lot of understanding that has to go to fix this number, because rest is determined by this. Okay, so the air quality standards are very, very important thing. We'll discuss that in a moment, but let me also tell you that so air quality standards, and so who should define the air quality standards? The basis, we know where we go for the basis. We go to a toxicologist, we go to the people with the medical sciences, we go to the people who have studied the air pollution and health effects. Okay, that is a different thing, but the standards, it means this is what we want to achieve. So the standards are generally, when we talk about the standard, this is somewhat country specific. Okay, as a nation, I decide, well, I want to bring down the levels, okay, to such and such level, and that become my legally binding value. Okay, it can be country specific. How to derive at the air quality standards we will see probably today or tomorrow, but there can be this can also be the country specific. What I want to define, make a difference is when you look the word standards, the moment you see this one, it has a legalistic value. Okay? It is a law the moment you see the word, the standard. And when you talk about the goals and guidelines, the guidelines are guidelines. Okay? If you know the Indian Constitution, you can almost draw the similarity to the standards as the fundamental rights, and suppose you have the guidelines, then guidelines will be equivalent to directive principles. Okay? In the Constitution of India, you see the fundamental rights, that is what is the government has to provide you with this, and directive principle is something that, well, government try, that well, we'll try our best that you get things. So this is something, well, it must be, okay. So whole thing is centered around here, but then planning can also go up to this thing. Okay. So that is what is the difference. So have you heard like WHO water quality standards or something? Okay. Remember one thing, the WHO cannot give the standards. Okay. This is a misnomer. Even if sometimes you find written in the books, it cannot be. Who is WHO? WHO cannot give you legalistic binding value. It's your own, the laws are always pertains to the individual country. It's our prerogative that what laws we want to fix. The WHO can be only the goals or guidelines. So that is always, never ever use the word WHO standards. Okay? No. Say no to WHO standards, but yes to the guidelines. Okay? How are we doing? Okay. And if we compare the water pollution and the noise pollution and soil pollution, we have to see what are the challenges. Air pollution, something which you can never, now we are talking a little bit science, you can never model as one dimensional or two dimensional. The problem is always three dimensional, more complex, very challenging. Okay. How do we, many times the groundwater, I don't know if you know much about the groundwater modeling. How does a model groundwater? Groundwater is very common way to model the groundwater is one dimensional, with the transport of the water and the pollutant. It just goes one dimensional way. Okay. Well, of course, some people do two dimensional also, but one dimensional modeling of the groundwater, movement of the groundwater as well as the transport in vertical direction is pretty good. How do we model the pollutant transport in the river? 2D, okay, largely generally 2D, okay, and whereas in air pollution, all models you will see will be three-dimensional models. So that is a challenge when we are talking about the air pollution. When we talk about, let's say, control, okay. Let me put up a question to you. I want to improve the water quality, let's say, in river Ganga or Yamuna, doesn't matter. What are the possible options I have? Treat the wastewater. Okay. What else can I do? Groundwater recharge, or I'm talking about the, well, maybe you're right. What you're saying is, suppose we are putting a lot of water into the groundwater will backflow towards the river and the river quality will improve. It means I can think of putting more water or some kind of dilution that I can, or it is possibly by man-made efforts. Okay. So control at source, fine, and so you can also manipulate the water quality by providing more dilution water. You can construct a dam, and we all do that, and then when there is a lean flow, when the pollutant levels could be high, what I'll do, I can do a little more discharge, and then as a result the water quality will improve, my fishes will survive. So what I'm saying is the medium of the transport, okay, can be controlled or can be regulated. Okay, that's what they are planning. Water harvesting, stop the water. Okay, the water harvesting is possible. Can I do the air harvesting? Impossible. I can't stop the air and say, okay, clean environment today, I'll hold on the air in this room, and tomorrow is going to be dirty, flush it out with the clean air. So when it comes to the control, in terms of the air pollution, I would say the regulation or change or control or should I use the word remediation? Okay. Remediation through how can I use medium, that is air, medium of transport, remediation through medium regulation, if I can use. Not possible. Simply. Okay? I can't regulate the water or I can't regulate the air, and if the air is bad, it's bad, people die. Whereas, okay, how do you save yourself from the dirty water? What are the other ways you can save yourself from the dirty water or polluted water? By boiling it. Exactly. So that little treatment at the lower level, in the air it is, I'm not saying it's impossible, but it's difficult. Okay? And you can buy the water bottles. The clean way of saving yourself. It's very difficult for ordinary people, okay, to really be carrying a cylinder on your back and doing your normal operation. Okay? So that is again impossible. So if I can use the word the direct receptor remediation extremely difficult, right? I can't be using carrying a cylinder all the time and things like that. Okay? So receptor remediation, we are talking about the control, the challenges that we face in this thing. The problem with the air pollution is the effects are instant. The bad effects are instant. Okay? Means that you can't avoid the air and then you will see immediately effect. Something like what happened in Bhopal. Suppose this had happened in terms of the water pollution. Suppose the MIC had gone into the water system. I don't think the disaster would have been that big. Okay? Not many people will die. Very quickly we'll say, well, okay, the water supply is contaminated, please don't drink this water. Okay? And then immediately information can go, people will not drink the water and things like that. And we can predict, okay, the people downstream of such and such place should not use the water. But here we can't do anything, people will have to breathe the air. Okay? So the effects are instant. So again the air pollution study, air pollution control or air pollution management becomes very, very challenging. As a result, the solutions or the effects are instant as well as chronic. There can be instant effects, which we sometimes call as the acute. You can write instant or acute effects. Okay. Fourth, what could be the fourth thing? Okay. Solution generally or solution be delayed. You have to act quickly. Okay, the solutions cannot be delayed. And little bit, let's talk about the human biology. You will be surprised that some of the effects of air pollution are irreparable. Whereas the water, the infections of the water, generally you are able to treat it through antibiotics and things like that. But some of the damages, suppose done to the lungs, you can't revive that. You have to live with that problem all through life. Okay, but that effects happens at many chronic levels and things like that. Okay, so in a way what I have talked to you, the remediation, or let's write that. The remediations can be three types: at source, at, or if you like, through, medium, control, remediation if you are using this word. So this is what is the most common for air pollution. But something, this is not, it is impossible, sometimes done. This is impossible, more or less. Why I want to slightly introduce you with receptor remediation is that this has become very standard practice to also to at least try to for the remediation at the receptor. For example, Taj Mahal. What has been done for Taj Mahal? Probably you will not be aware, but like all the traffic and transport which was very close to Taj Mahal, that has been stopped. A specific green belt and the forest has been designed about the Taj Mahal. The land was acquired through Supreme Court orders and things like that. Now we have the beautiful forest that has come up very, very close to the Taj Mahal. So in a way what we are doing the receptor remediation. Okay, and so one of the common thing to do the receptor remediation is design green belt. Okay, this also the technical word for the green belt is also called shelter belt. Okay, why I am talking about this is that this is really being tried, and there are some improvements that has happened in the air quality in some areas. So now the people from Delhi, well, they always have lots of influence and all big people are there. So what they are saying is a lot of pollution that is coming from Rajasthan in terms of the desert storms and the storm from the Thar desert. They say we should build the green belt at the border of Haryana and Delhi, and tall trees, and that is another study of the pollutant and their aerodynamics and things like that. There are some theses on this one. There's a lot of research on that, so that we can prevent the transport of the pollutants. How this transport is it is nothing. It's not a filter which you might be thinking that things get filtered and things like that. Generally what they do is, suppose this is your city, okay, or city or locality or residential colony or whatever. So what they'll do, and here the source, okay, and the source is, and then what you, this unfortunately I'm drawing in the plan, but then you have the some kind of tall trees here. Or suppose if you want to see, all of most of you are scientific people. If I see in section, if I take a section, you will find that there can be an embankment like the railway line, and then there can be tall trees. Okay, and then there could be another belt for the shelter of the some more trees here. Okay, so what will happen? The pollutant, and this is your city or area or whatever. So what happens? The pollutants are traveling like this. Some of them they might go through that, but largely what will happen? The moment there is disturbance, these pollutant or the gases or the flow will react to the obstruction. Okay, and once they react to the obstruction, they will try to climb the obstruction. We all know about that. Okay, and then as a result, they will, before they come down, Okay, eventually they have to come down and follow the same stream line as this one, and they will overpass the city. You might find a little problem with the visibility, but you see that this can overpass. So these things are also designed. So what I'm trying to say here is we will not do so much this in the course, but you should, there is a possibility of the receptor and receptor control, and you can design the shelter belts. There are lots of studies, a lot of research that is going on as to how to design. Some people even talk about the spacing of the trees and the height of the trees, and some people are even talking about the species of the tree that could be planted and things like that. So that's another arena of research and things like that. But this is possible. This is impossible. The most of the things which we'll talk later in the course will be the control of this one. So so the philosophy of the air pollution control is, well, we can't go that far today. Okay. Now can you say that something? Can you comment on to something about the pollution control at source? So the philosophy of the air pollution control is reduce the emissions of the pollutants from the source so that its impacts are less than the desired concentration at the receptor. We don't want to make zero pollution. We don't want to close down the factory. We don't want to say, well, stop everything. But what we want to say is to reduction of the pollutant emission to a point such that no noticeable adverse effect associated with the pollutants exists at the receptors of our interest. Okay, that is all is the philosophy of the air pollution control. Okay, and now tell me, who will tell that, well, the emissions are there, okay, whether the impact is within the nominal region, or in the impact is within the safe regions, or impact is not within the safe region? Who will say that, and how can we say that? We understood the objective. The objective is to safeguard the receptor, bring down the pollution level to the below that concentration. We also said that, well, the controls which are possible to us. So who will tell us that as to where that how much control needs to be done? These are the job of the air modelers. They say, okay, emission quantity is Q. So they are the one that try to give the Q, which can be an array. Why array? There can be many sources: automobiles, house heating, cars, and the modelers will look at this emission, look at the transport changes and what's happening, and what is the concentration that is observed. Okay, so the observed concentration must be while we are designing the air pollution control less than air quality standard, right? If we have done that one, we have done the pollution control, we have met the objective, and we have done fantastic job. So that is what all air pollution engineers try to observe is, if I can use the word standard. I have defined the standard, will go a little bit more. So this is what is the objective as well as the philosophy. And to do this one, you need to understand this, you need to understand this, okay, and you need to understand this. And who can provide this understanding is the air pollution modeler. So modeler should have reasonably good idea of this, very good idea of this, okay, and some idea of the impact, and that's how this is done. So sometimes observed is model calculated, or sometimes it can be measured or monitored also. So that brings the concept of the air pollution measurements, okay, because our objective, we have to make sure that this is what is happening. So you do the measurement, or you do either you do the modeling. So modeling you can do for the existing sources, modeling you can do for the future sources, and then you can use the information of your modeling and science in environmental planning, siting of the industry. Okay, we'll stop here, but what I tried today is to give you a little feel of the air pollution system, what are our objectives, what we want to achieve, more in terms of the philosophical and with some reasoning, not so much of science and technology. But the course that we will go is that we'll be back and forth, we'll talking about different things, depending on how we are doing it, and eventually at the end of this course these things will be interconnected. Okay, that will be at the later stage. So we'll talk about the making of the standards in the next class, because that's very important, because this is the keyword, such a concentration. So standard is important because everything is centered about the standard. And there are lots of discussion to give you a little feel that in US, for example, they are fixing the standard. Sometimes it takes 4 years to fix the standard, 5 years. The reviews are huge, you know. And India also we try to do something similar. So that, because if you get that number wrong, okay, its implications are huge. If you get the number wrong, you can destroy the ecosystem, you can kill the people. And if you get the number too conservative, you can destroy the industry, right? We don't want to do that. We want to do a good job. So that fixing of the standard is very, very important. Okay, and rest of course is the engineering and technology and things like that come out. So we are talking at the philosophical level. We'll stop here and we'll continue whenever we have the next lecture. Thank you very much.